Python09 Advanced Algorithmic Thinking and Coding. Okay, in this lesson we'll go on with our search engine. We have until now have learned how to get a web page and take all the links out of it. The only thing we did was printing the links. Now we'll use those links. First of all, we'll put the links in a list because obviously our aim is not to print them. But then we will use those links to crawl the web. What does it mean? It means that I don't know whether you are expert with a search engine. However, I think it's explained in any basic computer course. The search engine uses the links to find other web pages. Those web pages are examined and uses the links in those web pages to find other web pages, and so on. This technique is called crawling. Okay, so now we'll build an engine which crawls the web. So starts from a single web page and goes around, takes all the links and examines other web pages, and so on and so on and so on. Okay, it's called a web crawler. Okay, we start with the previous codes. I make some little adjustments. Okay, slightly modified. Now it works also for single quotes, and I make some little adjustment. Then I set up an address for testing, because if you test a web crawler with a real web page, well, you will find the real links that will contain a lot of other links, and in some minutes you will have to crawl the entire web, trillions, quadrillions of pages. Okay, so I have set up this little website test, which contains only 4 pages, and they don't have links to the rest of the web, so it's isolated. Okay, so this is the code. You have seen it already. It just takes this web page, okay, that's it, and extracts the links from it. Okay, fine. Okay, now we want to use these links one after the other to find other web pages. Okay. These web pages will find other links, and we'll use those links to find other web pages. Okay. However, we have a slight little problems. We must tackle with it immediately, because otherwise we will stuck our computer. Imagine that our web page A, has a link to B. Okay. And imagine that B is a link to C, and something which is pretty common, C has a link to A again. Or much more frequently happens that A has a link to B and B has a link to A. So if you simply examine all the links contained in each web page, here you will examine the links of A, therefore find the existence of B. You will examine the links in B and find the existence of C. You will examine the links in C, find a link to A, and you will go on examine the links of A, find B, and etc. And you will go on forever. So this is a real danger. So you must try to handle this problem. I now don't invite, I order you to stop the video, really stop the video, and do it manually. So imagine you have 3 pages, A, B, and C. Each one contains only one link. Okay? A to B, B to C, and C to A. Okay? Imagine you are going to do it manually. Okay? How would you do it? Okay, now stop. Did you stop? Okay, let's see how would we do it. Okay, I will do it like this. I would examine A, found a link to B. Well, I need to write somewhere the fact that I have already examined A and I have to examine B. So I need to write this true information somewhere. So we'll set up a page with web pages already examined, A, okay, and a page with web pages to examine, B. Okay, this is already examined to examine. Okay, Well, we can make it larger, so you see better. Okay. Now, after having finished examining A, okay, I look in the list and see what's next. Ooh, B. Okay, so I examine B. Okay, so I delete B from here and put B here in the list of examine. Okay, inside B, I found a link to C. Okay. But pay attention, before writing it here, it would be a good idea if I check whether the link to C already appears here, and in this case I don't write it anywhere because it means that I have already examined, or whether it appears here and I don't need to write because it's already in the list. Okay, if you have to buy sugar at the supermarket, you don't write it 20 times, one is enough. Okay, so C, does it appear here? No. Does it appear here? No, because it's empty. So I write C. Okay. Okay, now I'm finished with B. Now I look what's next in the list. C. Okay, let's examine it. So I'm examining C, so I remove it from here and put it here. Okay. What do I find inside C? I find a link to A. I should write a link to A here, but before doing it, I check, is the link to A already here? No, it's empty. Is the link of A already here? It means that I have already examined. Yes, it is. So I don't write it anywhere. Don't write it anywhere. Then I go on. What's next? Nothing, it's empty. Finish. Okay. So you keep two lists, the list of already examined web pages and the list of web pages to examine. Whenever you find a new link, you must insert it here only if it is not already here and if it is not here. Okay. Now, clean my hands. Oh. Okay. This is what. So we must keep a list of web pages to scan, to crawl. This one. Crawl. And another list of web pages that have been scanned, called. Okay. When we scan a web page, we move its link from to crawl to crawled. When we have new links to insert into crawl, we have to check whether they are not present in crawled or into crawl. Okay, now I need to modify only this part. I don't need to modify the other two. If you want, you can copy the entire code, but so okay. So let's modify it. So I have a while. For the moment I write true, but I am planning to modify it in future. Modify in the future. So I can just write what's inside. What do I have to do? I have currently here in page address an address and in page a web page. Okay, I have to go through all the links there, so using this thing here. Thank you, Ermanno, for having suggested this nice feature. Okay, so I go through all the links inside my page. Okay, if I find the link, it means n is not larger than -1. And I have also to insert this one because I found some empty links. Instead of printing it, I would. Well, first of all, I put the fixed link here. Okay. Then I check whether the fixed link, if all, is not in. I need the list to crawl. The list starts as empty. Crawled. Okay, no, to crawl is not really empty. It contains page address. It contains the first one. So it contains this one. Okay. Okay, by the way, here before doing everything I have to move this one here. So, well, we will do it later. Let's write a note. I have to move the address from to call to call list. Okay. If all is not in to call and all is not in called, okay, in this case I to call dot append all. I append it to call. Okay, I don't think I have to do anything else. Okay, except that here I have to move the address from to call a list. So page address, I pop it out from to call. I write pop 0, so I always pop the first element, because if I write just pop, I pop the last element. Well, it doesn't change too much. Usually it's better, however, to start examining the first links in the page rather than to start from the last ones. So here I extract, then I to called equal dot append page address. Okay, and also this one doesn't go here but goes here. Okay. Okay, so page address is taken from the list. Okay, remove from the list. I append it to the new list. Okay, done. Okay, let's write some comments. Here I go through all the links in page. Here I move the first element of to call to the called list. Write some comments so the people who will read the code in the future will understand it better. Here okay. I think we have everything. And here, okay, after all this thing, I will have all the links inside the called, okay, because sooner or later all the pages have been called. So I just print a list just to have something, otherwise this thing here examine all the web pages but doesn't show anything to me. Okay. Or even better, we can write, look, we can write here, print, I am starting to examine page, and we put page address. So it tells us which pages it's starting to examine. Okay, and at the end it will print out the list of the examined pages. Does it work, the plus of a list and a string? Let's see. No, obviously. No, it's not. No. Non is wrong. To crawl is not defined. There is the capital L, R. Here. Wait, there is, okay. Okay, there is a problem that true, modify in the future. So we'll do everything until to crawl is full. So until len of to crawl is larger than, until there is something. Okay, these two cannot be joined together. And what if I convert crawler to a string? No. Okay, I am starting to examine page blah 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 blah. Examined pages, these ones. Okay, let's see, I teach you a trick. This one should put a space, let's see. Yes, it puts a space. This one puts an empty row. Okay, fine. Okay, so this is the web crawler. It works fine. The only thing was the difficult concept of the two lists. But difficult. Okay, there are, however, some problems. Try to run it not on the university website, but just simply on my website, and your program will crash. That's it. I just try to run simply on my website. And you see, it starts to find a lot of web pages. As soon as it finds links, for example, to the university, you will have tons and tons of things. Can you see? It starts to, when it examines links such as this one, in other universities, it will start to find tons and tons of links, and now very soon will go on forever, basically. Okay. Oh, YouTube playlists. Cosinant communication, there are things I don't even know I put a link to. Okay, so it will go on forever, so let's stop it, because it will start to scan the entire web. So, how to deal with it? We have to set some limits. The easiest way is put a limit on the number of pages that it scans. As soon as the limit is over, stop. And this is why I choose to pop the first element and not the last one. Because in this way, because if you pop the last one, the last web page that you have examined will have the last link examined. So it will be a last in, first out. No, we want the first in, first out. Okay. So the very first link which was put inside the list will be the links which will be examined first. If you instead write pop like this, you are taking the last link, and it's the last link inside will be examined first, which is not fine. Okay, let's see how to set up some limits. Okay, the first limit is limiting the size of crawling. Let's see. Okay, Ctrl C. Ctrl V. So we set I try to make it similar to the code I have here. So let's set up limit visited pages, for example, to 30. Some of you have the bad habit, whenever you set numeric values, to write a number directly inside the code. It's a very bad way, because if for any reason you have to change that number, you will have to go through all your code and look at all the places in which you have written that number. So please, writing raw numbers inside the code is never a good idea, unless you are very sure that the number will never change. So this, I will change it 20 times, so it's better to write at the beginning and then use limit visited pages. So how can we set up this limit? We have to count how many pages we have visited. So visited equals 0. Okay. Whenever we visit a page, here, where is it? I am starting to examine page, visited equal visited plus 1. Okay. Let's write it. Okay. So we have incremented visited. And now we can, we have also to write, where is it? Here. And visited smaller or equal than limit visited pages. Okay. Well, obviously, if you test it on test, it will never be. Let's test it at the university website, which has a lot of links. So 30 is too much. Let's see 3. So we will visit 3 web pages. I comment this one, otherwise we will produce too much output. Okay, ready? Oh, but no. Okay, let's go. Oop. So it's examining the web page of the university. It's examining the web page of the university again, because there is the HTTPS, which is officially, well, in practice it's the same website, but it could be different. So the German version, the Italian version, then stop, because so at this point it's better if we print also. Okay, all the web pages to be examined. Examine the web page. HTTPS. Okay. Can you see it has examined this 4, and this was the list of things to be examined, which is very long and have never been examined because. However, why did it examine 4 pages, and if I set it the limit equal to 3? Because it starts with 0. Okay, so I have to make this one if I want to the limit really to apply. Okay, stop at 3. Okay, fine. Okay, let's make some more. 5. The German version, the Italian version. Oh, okay, this is not really a web page. It's the image, the Apple Touch icon. Okay, and if I set 20, open. Okay, now it's examining. It's not really web pages, by the way. There are pictures, so they don't contain any link. Okay, and stops here. Okay, so this limit was very easy. You just set a limit on the visitor web pages. Okay, now let me copy all the code. Ctrl C. Let's see another much more interesting limit. Ctrl V. A much more interesting limit is setting a limit to the depth. We say that the web page of the university, the one we start with, is at depth 1. Okay. The links towards the web page, the links that this web page has are at depth 2. The links that this web page have are at depth 3, and so on. The links that these web pages have are at depth 4, and so on. It's much more interesting to set a limit on the depth, because probably you are not interested in pages which are very far away from the university website, so which are 20 links far away. So you want to limit the thing. So if you set a maximum depth equal to 1, you will examine only the university web page. If you set maximum depth equal to 2, you will examine the university web page and all the links which are contained, all the web pages which are linked from the university web page. If you set depth 3, the other, and so on. Obviously, the more depth you set, the more web page it will explode exponentially. Okay. In order to do this, we have to change our data structure. Until now, our list, to crawl, okay, was just a plain list containing the addresses of the web pages. You can see it here. What is it? Okay, this is to crawl. So just contains the address of the web page. Now we need to know at which depth each web page is. So this list will be slightly different, will be more complex, will be built like this. It will be a list of lists. So we contain inside small lists, each one with an address URL and a depth, which is a number. Okay. So let's see. So to crawl now is page address, comma 1. Okay, can you see? Oops. So it's a list which currently contains only one element. It's www.newbz.it followed by comma 1. So it means that it's at depth 1. Okay. Page address. Okay. Now when we pop it, pay attention, because when we pop it, we get this thing here. Okay. So now we have to pop it and to get. Wait. We have to. Let's make it temp. Okay, no, there is a trick. Don't worry. Page address, page. Okay, when you pop it now, you get a list, because you get something like this. Okay, using this trick, do you remember we had a little talk about multiple assignment? You will assign the first element, which is the page address, to page address, and the second element, which is the depth, to page depth. Okay. Okay. Now we will. List crawled doesn't need to keep the information on the depth, so we just append only the page address. So it's a traditional list like before. I'm starting to examine page address. Let's write also at depth str page depth. Okay. Okay, increment the number of visited. Okay, we get a link. Okay, here when we append it, we append the URL and the depth, which is the current depth plus 1, because these are web pages, are links which are contained in a web page of depth, page depth. Okay, so plus 1. Okay. That's it, I think. Okay, currently we don't do anything, so we don't put any limit on the depth. So let's see. Oops. Invalid syntax. Sorry, at depth. Maybe it's better if I put it between quotation. There are too many quotations. Okay, I'm starting to examine at depth 1, depth 2, depth 2, depth 2, depth 2. They're all at depth 2 because they're all containing unibz.it. Let's see on my website. Test. Okay, depth 1, depth 2, depth 2, depth 2, depth 3, 3, 3, 4. Can you see that it's examining the same one more than one time? It's examining the same one more than one time because there is a problem in the test. Here. If all not in to crawl. Okay, this one is not correct now. This one is correct because crawled still contains the list of the crawled elements. How can we fix this one? I will need not into crawl. Well, okay. We need to avoid. Okay, we need to keep also all the list to crawl. So to crawl list only. But I don't like this solution particularly, but seems to be the best one. So I keep a list exactly as before. I don't like it particularly, but here I have also to go list only dot pop 0. Okay, and to call list only. I need to keep an old style list, because otherwise I cannot do this check easily, because each rule will have its depth. And okay, to call append and to call list only append the rule without the page depth. Okay, name error. Equal. Okay, now it works. Test 2, test 3, test 4, test. Okay, they're all different. Okay. Examine pages to. Okay. Currently, so the only thing we have added is the depth. We didn't add any limitation to the depth. Now, how can I add a depth limit? First of all, let's see. Limit depth. Let's say 4. Okay. Let's set it to true better. And we start for the university website. Okay, so here, if for any reason I find a web page which has a depth which is at the limit, okay, it's pointless. I will not add the new URLs, the new links that I find. So if URL not into call list only and URL not in code, and okay, here now if depth, page depth, if page depth, okay, smaller than depth, than limit depth, okay, I do as usual, okay, else, which means that it's currently at the limit, or better, let's check it, elif okay, if it is currently at the limit, it means that these links should not be appended to the call list, okay, because I will never examine them. So just to remember that this link exists, I will make a skipped list, otherwise I will lose these links forever, and I will append this list to the skipped, don't need this one, okay. So if the page depth is smaller than the limit depth, the link containing that page will be added to the call with a depth of +1. If the depth is already at the limit, it means that the links containing this page will never be examined, so we'll add them to the skipped. And if the depth is larger than the limit, it can never happen. So it can never happen that I am scanning a web page whose depth is larger than the limit, because I never added any web page with depth larger than the limit. So okay, so imagine if the limit was set to 7, okay, if I scan a page whose depth is 6, it will have links whose depth will be 7, and I will add those links, okay. If I scan a page whose depth, and this is this case here, if I scan a page whose depth is exactly 7, it means that its links would have a depth of 8, and I don't add them, so I put them in the skipped list. Okay. it can never happen that I'm scanning an address whose depth is 8, because I never add to the list addresses whose depth is more than 7. So in this case, I should never be here. It's sometimes a good idea to put things like this, because if you see that it prints, hey, I should not be here, it means that there is a problem. Print skipped. Okay, ready? Oop. Clearly the list is rather long. At depth 2, university has a lot of links. The web page of the university has a lot of links. What's the maximum depth? 2. I have a limit on the visited pages, so it will stop for that one. So it will stop for this one. Let's see. Okay, visited pages 20 reached. So the examined pages are this one, 20. Okay, pages still to examine are this one, each one with its depth. Some have depth 2, okay. Pages skipped. So these are all the pages at depth 3 which have been skipped because our maximum depth is 2. Let's do it slightly more serious. Limit depth 4, number of pages 200. Oop. What did I do at home? Well, it will stop at 200 probably. Can you see it's starting to examine real web pages, so the privacy, the profile, the organization, the research page. Okay, it has finally finished. Let's see. It has examined 200 web pages, arrived at depth 3, so it has also examined web pages contained in links, web page whose link is contained in a link, who is contained in a link in the university. This is the list of examined pages, blah 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 blah. It's long, it contains 200 web pages. Okay, now here's the link of the pages still to examine. Where is it? Here, page to be examined. We didn't examine them because we reach the maximum level. Okay. And at the end, the list of pages which were skipped because they were over the depth. This is the list of the pages still to examine. It's pretty long. Is there a way to go directly to the end? On the Mac? No. So, okay, however, somehow at the end, but we can print it again. Print skipped. It's 0. It's empty. Yeah. Because we never reached the limit. What was the limit? 4. Okay, so we never reached it actually. There is only one little thing that I have to set up here. If page depth is equal to limit depth, I have to add this one to the skipped only if all not in skipped. Only if it is not already in skipped. Otherwise, I will add duplicated links in skipped. Okay, goodbye. Where is the stop here?